In today's episode, we are going to take a look at how you use machine learning in Apache Spark. Apache Spark already comes with the standard machine learning library, which we are going to use here. So for our example, we are going to take an example of predicting house prices using the linear regression algorithm. If you don't know what's a linear regression algorithm, I have a separate video on it. I will include that in the description so you can go and check that first. So what we are going to do, right, as a part of our machine learning example. First, we have a house prices here. So we have, for example, here we have a CSV file with the house ID, with the how many bedrooms that house has, and how many bathroom we have, how many square size of in the square feet. We have a location, year built, and the price. So we are going to do that. We are going to use this CSV file. First, we are going to load this data set, right? That's the first step. After that, we are going to encode the categorical features. So what's that mean? So for example, as you can see here, all the fields here are numbers except the location, right? That's in that's a suburb or city center and so on. So what we are going to do is we are going to map that into the numbers, the third step, we are going to assemble the numeric and the encoded features. We have only one encoded feature here, which is the location, and after that we are going to train our model, and then we are going to evaluate the error and show the predictions. Now let's go step by step as usually. So what we do here, we are creating a Spark session, and the first one is that we are loading our CSV file, right? So we are loading our CSV file, our house prices CSV file, and the next step is that we are showing that, okay, so our CSV file is loaded, and the next step we are encoding the categorical column. We have only one location here, so we are mapping that to numbers. So for example, as an example would be that let's say our location is not the suburb or city center and so on, it's cities, let's say New York, Boston, Chicago, and so on. So for each one we are assigning a number, so we are basically indexing that. For example, let's say the New York is 2, we are assigning number 2. For Boston we are assigning 0, for Chicago 1, and so on. So after encoding our categorical columns, so what we do is in the next step we are combining features into one single vector, right? So we are combining features. So features are, in our case, what are the features, right? It's a bedroom, bathroom, size in the square feet, year built, and the location. So these are our features, and now we are combining them. We are combining those features. We are combining the fields that we have into the features. What's the feature? So let's say that you are buying a house, right? So which features you would look at? So you will look at which features you want to take into consideration. So you would probably take into consideration how many bedrooms there, how many bathrooms there, size square feet, year built, and in our case we are taking all of them. We are taking all of them as our features. That's what we call a feature in machine learning. So which features we are taking in order to predict our result. So we are taking in this case all our features, and we are combining them into one vector. So here what we are doing, we are gathering all the values, we are creating a vector with our features, we are taking all our features, and then we are going to use them in our machine learning algorithm. In our case, it's a linear regression. So what we usually do is we are multiplying whatever our feature is to the weight. So it doesn't matter which algorithm you are using, linear regression or let's say the neural network and so on. It's all about the weight. It's all about adjusting these weights, right? So we are taking the features and we are multiplying them to weight. And once when our algorithm start to train on the data, so basically what it does is it adjusts these weights. It adjusts these weights in order to predict more precisely. Again, if you don't have any experience with the machine learning, I would advise you to check my linear regression video. So there, in details, I described what is exactly linear regression algorithm that we are using. It's the simplest algorithm that's out there, and how exactly why weights are important. So in the next step, so what we do is we are defining our regression model. Again, the features, we are taking all the features, and the label in this case, in the machine learning, we are calling the label. So what is our output should be, right? So based on the features, this is our output. So based on these features, we are predicting a price. So, and then in the next step, what we do is we are building our pipeline. So basically, we are taking our encoded, we are encoding text to the numbers, so which we have done earlier. So we are taking the assembler, which is all our features, and we are taking our algorithm that we are going to use, right? In our case, we are using a linear regression. So that's it. After that, so what we do is here, we are taking our pipeline, we are creating our pipeline, and we are training our model. So we are training our model, and we are transforming. Transforming, in our case, so what we do is we are training our model, and at the same time we are predicting the price. So we are predicting the price for each of them. So for example, we are predicting the price for house 1 and the house 2, and we check that how those predictions are precise comparing to these numbers. So for example, in this case, after we train our model and predict the prices, we are going to select the 10 predictions, right? 10 predictions that top 10 values that we have, right, in our prediction. So let's run it. I think that it will be more clear. So what we have here, right? So what we have here is that so we use these features. We use the bedroom, bathroom, location, and the others. We use that in order to predict the price, right? So in order to first we train on this data here. We are training on this data here, and at the same time what we do is we are training on this data. At the same time, then we are predicting for each of them, for each of the field, we are predicting that what's the average price here. So what is the price, right? So what it predicts for us is, as you can see, the predictions are, for example, the real price is 180,000, but it predicted for us 142, 166, and so on. So after that, after we trained our model and we have our predictions, now we can evaluate the model accuracy, right? So for that, we are taking our label, which is the price, we are taking our predictions, and we are setting the metric name, which is in our case that the root mean squared error, right? So we are checking that what is our error here, and our error is here. Our error is here 26,245. So what it means? It means that on average our model is, and the error is 26,000, right? So which means that the price could be that the 26,000 either on average 26,000 more or less from the actual price. For example, in this case, in the first case, it's more less than the actual price. In the second, it's also less than the actual price. In the next one, it's more than actual price, and so on. So on average, our model is 26,000. 26,000. The error is 26,000, right? So for each of them, we can also calculate what is the percentage, right? Let's say that for a house with the value of the 420,000, it's if we take what is the error rate, so it's less, but for the house with the value of 180,000, it's not that much, it's not that good. How we can correct that? The way we correct it is we are using more data for training, and again, it all comes down to adjusting the weights. So we are using more data, and after using more data, so we can adjust our weights better, and that our model will predict the more precise price. Okay, that's it. That's how easy to use the machine learning in with the Spark ML, which is again part of the Spark ecosystem.